Happy Thursday afternoon to you, my dear grade 11 pre-calculus class. Hope things are going well this week. Today is a continuation, I say that every class, a continuation of factoring and working with denominators on rational expressions. So let's just get going. In this question, or this lesson, we're going to add and subtract, but this time our denominators are going to be different, and they will either be monomials or binomials. So we need to remember one thing before we begin. Anytime we look at denominators, we need, if possible, to simplify it. So we need to factor the denominators before we begin. Now, if you look at our first question, there's nothing that needs to be done here. All we're going to do, for factoring that is, all we need to do is have a common denominator. This is what we did yesterday in class as well. So I have a 10x as my common denominator, and what I will do is take my 3, that is my numerator, and multiply it by the 2. Why 2? Because 5x goes into 10x 2 times, and then whatever I did on the bottom, I need to do on the top. The next term will be the 3, and I will notice the 10x is the same as the new denominator, therefore I just multiply it by 1. The answer, 6 minus 3 over 10x equals 3 over 10x. Again, we need to do our non-permissibles. X cannot equal 0. So that's really basically what we did yesterday. We're going to move on though, because now we recognize that we have a binomial and we have a binomial, and those are two different binomials, so we will have to combine them. But the first thing I said up here was we need to factor the denominators. So I'm going to rewrite this question, and on the bottom I'm going to pull out the 5's, and I'll end up with x plus 1. And then I'm going to rewrite my second fraction, pull out the 2 out front, as it is common to both terms in that binomial. Now, notice what I have here. I have x plus 1 that is common to both. So that will definitely be on the bottom, x plus 1. Now, what else needs to be included in that denominator is I have to account for the 5 and for the 2 as the whole number. So if I multiply those together, that will, just like a regular finding your common denominator with a regular fraction, we can just multiply those together. Now, when I do that, I recognize then that the x plus 1 here is the same as my new denominator, so I don't need to do anything there. All I need to do is say, hey, how many times does 5 go into 10? That would be 2. So I'm going to take my 4 and multiply it by 2. And the same thing here. I know that 2 goes into 10 5 times, and I will multiply that with the 3. Actually, I kind of was doing it the other way. I was putting the 3 first, and then I will multiply it by the 5. That will take us to a common denominator of 10. When I do that, I'm going to add my 8 and my 15 together. I'm going to leave my 10 out front of my denominator. I end up with a 23 over 10 x plus 1. That is it, and my non-permissible would be x cannot equal negative 1. That's it. Next question, we are going to do the same thing. We are going to simplify the denominators if we can. This x squared, nothing can be done, but I can do something with the second fraction. X is common to both terms, so I'm going to pull that out, and I end up with x plus 2. Now, what do we need for the denominator? Well, there's nothing common here except maybe the x. So I'll put an x squared here, and I will need an x plus 2. So I'm combining the two. I'm not including this x because that will be taken care of with the x squared. So when I do that, I put my 1 down. What do I need to multiply the top by to get this denominator to be equivalent? That would be an x plus 2. And on this side, we have everything we need with this. I'm going to just highlight it. I'm comparing this to this, and the only thing I need to add would be an x, because this has an x and I need an x squared as my new denominator. So I'm going to put multiply the top number or the numerator by x. All right, what do I do now? I'm going to put my my denominator back down, and then along the top I'm going to just multiply through the bracket and collect my terms. The x's actually cancel out here on the top, x minus x, so I'm left with a 2 on top, and on the bottom an x squared x plus 2. That is it. That's the answer. And my x cannot equal, in this case, it cannot equal 0, and it cannot equal negative 2. All right, so just a little bit more algebra. We're just taking all the skills we have and we're using them in these rational expressions. Next one, we're going to simplify. We need to state the restrictions, and let's have a look what's common here. So in this case, I have an x minus 2 in both, so that's definitely going to go on the bottom. But also notice I have an x plus 1 and an x plus 4. I will have to include those as my common denominators as well. So down below, my common denominator will have to include my x plus 1, my x minus 2, which is common to both, and my x plus 4. I need to account for all of the denominators. Now, I go to my first expression and I say, all right, what is taken care of? What is included in my new denominator, and what am I missing? And in this case, this x plus 4 is missing. So I take my 5 up on top and I'm going to multiply it by my x plus 4. I'm going to go on to this expression. What is missing out of this expression? And in this case, it will be, it has the x plus 4, it has the x minus 2, it's missing the x plus 1. So I take my 2 and I'm going to multiply it by my x plus 1. When I do that, I will multiply through the bracket. X plus 2. On the bottom, my denominator stays the same. And I collect my like terms. 5x plus 2x is 7x plus 22. And I rewrite my denominator. For those of you who don't like to write, you're going to not like this unit very much because we do an awful lot of numbers. They are giving you quite a bit of room in these in this book for questions, but if you run out, you can certainly add extra pages in. X cannot equal, I look at the bottom, x cannot equal negative 1, x cannot equal 2, and x cannot equal negative 4. Typically, and it cannot equal. Typically, we like to put them in order. I haven't done that. I should probably go negative 4, negative 1, and 2. That would be probably a better thing to do because they are in order, in ascending order. That was the answer, and those are the restrictions. Let's go on. Next page. The next part of this, we are going to just simplify again. Again, just a couple extra different kinds of questions that you will experience. My 4 is going to stay up on top, and the first thing I said is we always need to factor or simplify your denominator. So in this case, it's a difference of squares. So I immediately go to p minus 1 and p plus 1. And my other fraction is going to stay the same. It's p plus 1. Now, what is the common denominator? We have p plus 1 in both. We'll use that, and we will also have to include your p minus 1 that comes from the first expression. When I have that, I am going to look at my first fraction and I go, hey, I have a p minus 1 and a p plus 1. That's what my new common denominator is, so there's nothing I need to multiply the top by. Over on the second expression, I have a p plus 1 as the denominator, but I am missing a p minus 1. So I will add that to the top. Again, I will just rewrite the bottom, p plus 1, p minus 1, and then I will just multiply multiply my 2 throughout the bracket in that second expression. I'm going to run out of room. I'm going to go up here and go 3. Let's see, we got a 4 plus 2p. Oh, I made a mistake. Let me just go back here. That 2 was supposed to go through the bracket, and I ended up with a negative 2 here. So I don't have a 3. I have a 2p plus 2 all over that very basic denominator. And the only other thing that I've suggested to you or encouraged you to do in the past is making sure you simplify it as far as possible. So if you notice, that first numerator has to have a 2 pulled out to simplify it. So there's what I've got. I've got a p plus 1 and a p minus 2. Oh, but we learned something in our previous lessons. There's a p plus 1 up here, and there's a p plus 1 on the bottom. I can cancel those out. I can do that because this is multiplication. There is no adding between the terms. These are monomials. So I'm left with 2 over p minus 2. Did I do something wrong? Yes, I did. Oh, that's 2 mistakes in one lesson. This was supposed to be minus 1. That's why. I'm going to just take these out. I don't want to redo this lesson. We'll just replace those. Sorry, I don't know where that 2 came from. So this would be the answer, 2 over p minus 1. And after that, I put in my restrictions. P cannot equal, and in this case, it'll be a positive or a negative 1. There is the answer. It also goes on to say in your notes that in example 3, the numerator of the answer had a factor in common with the denominator. That's what I explained. That's why it's in red. We can further reduce. But we must always check to see that our answers are fully reduced. So I will need you to take it all the way to the end, is what that's saying. All right, you can go and stop if you'd like and do a couple questions, 1 and 2, and then come back and start this video again. What I've got now is a trinomial denominator, so we just keep getting a little bit deeper. Notice we're going to factor, not the first term because everything is pretty straightforward there, but our second term. I'm going to rewrite my numerator, but my denominator has to be factored. It's a simple factoring by inspection, x, and my other terms will be a 1 and a 3, and my 1 will be positive and my 3 will be negative. All right, now that I have this, now it's pretty well the same as the question before. All I will need to do is have a common denominator, and that would be the x plus 1 and an x minus 3. So what do I need to do with my 2? Well, I am missing an x subtract 3, so I'll multiply that. And over on this side, I have everything I need. I'll just throw a 1 out, but it doesn't necessarily need to be there. So I have everything I need on the second expression. Multiply through the bracket. Remember, in this case, it becomes a positive 1. That negative has to go right through the bracket on the second expression. And my bottom, my denominator stays the same. I collect my like terms. I end up with x subtract 5 and x plus 1 and x minus 3. That is the answer. X cannot equal negative 1 and positive 3. The next question, same idea, but this time we have 2 fractions and both denominators will need to be factored. So I'm going to just rewrite this again. And simple inspection. Oh, sorry, that's not an x, it's a y. Y y to 1 and